Hello, my name is Joseph, and today I'll be presenting the data science project for Team ISS for class 6330. An overview of the project is the introduction, the data set, data preprocessing, the visual analysis, validation analysis, prediction analysis, and finally the conclusions and future work. So the problem set we were given was that we needed to determine what the percent difference between the historical consumable usage rate we got from a CSV and the actual calculated usage rate in emissions time frames between resupply. After that, we were instructed to find the min-max forecasted quantity of each consumable category using a 90% confidence interval at a date 60 days beyond the latest actual data point. The actual data point being, I believe it was 9/15/2023. So the data set initially had, I believe, 40 or so columns with almost 6 million rows. And so there was a lot of pre-processing required to actually make the CSV usable. What this pre-processing looked like was we first determined the shape of the CSV, the data frame, and we identified which data types each column's values contained. And we had to include a header, and this was kind of the first part we did was we found the relevant columns and determined which ones we needed and which ones we needed to remove. And we also formatted datetime as a datetime data type to more easily filter and use the duplicate or the drop duplicate function. So we removed the not a number values, and when we used the drop duplicate method, it was almost 80,000 rows that were deleted. And in order to do that, like I said before, we needed to switch the data type to datetime and remove the hours and minutes from it. So the numerical and categorical, I suppose, categories were something that we first needed to distinguish between columns, and so for this one we just used the category names and determined just very high level, so nothing in particular, but we just looked at the quantity for every consumable category to see just a rough estimate of how many were there. And we also had a density to height plot graph and a histogram of width with density curves. So this is a visual analysis of kind of just like the height and width for the scatter plot, or a scatter plot for the height and width, as well as a few other just visual guides to see if there were anything obvious, low-hanging fruit, so to speak, to dive into more. So to the left you have the box plot of width, height, and length, and that was kind of just to determine if in future work we would calculate the volume and potentially the constraints we would have for resupplying with respect to the volume of the cargo. And to the right, we have status of items over time. One interesting thing to note here is the gaps between some of the dates, especially between March and April. There's just no data there, and this is the first time we determined that the data set we received had a lot of just missing data. So looking for trends. So the first thing we did, in the first item we kind of took a deep dive into was ACY inserts. And so we grouped and filtered by the category name ACY inserts after we did a bit of cleaning. And we needed to create more columns that kind of showed different things. So firstly, we did a multiplication of 50 because it was determined in one of the Barrios meetings that 50 ACY inserts were in 1 unit of ACY inserts. So 50 to 1. So that's why there's multiplication of 50. The ACY stow difference is the daily difference that we saw. The negative trend is only the negative daily differences. So this just omits the resupplies. The cumulative negative trend is just a cumulative sum of all of the negative daily differences. And the stowed difference cumulative sum is just that. So if you see on the top right, there is a graph of the cumulative stowed difference, and it kind of shows trends for the data over time. And to the left, you can see just the negatives. So that will be the graph that we use later on, or the data set we use later on for the linear regression models. So in this slide, we kind of visually wanted to determine what the longest interval between resupplies was. And so if you see between, let's see here, May to roughly November, you can see that it was the longest time period between resupplies. And so we used that interval and we accounted for the crew count within that interval and determined that it was a good time frame for the linear regression model. So we did what we did in the previous slide with all of the consumable items and basically assessed what interval to use based on visual analysis. And we compared the consumption rates we got for those intervals with the historical rates, and the percent difference is seen to the right. One outlier we found, because most were within a reasonable percent difference, was for food US. It was 1,000% different. So I believe it may be a result of potentially different unit conversions. Like I said before, we took account for the average crew counts during those intervals, and from the codice below, we declared the historical consumption rate, we calculated the slope, and we calculated the consumption. So these are the results from all 6 consumable items. And as you can see, the percent difference for the first one is 6%, second one is 57%, and the food US is 1,375%. Yeah. So in this slide, so the previous slide was for those longest intervals. However, for this one, it's for the whole data set. So from January 1st, 2022 to September 15, 2023. And as you can see, it's not significantly different from that interval. So for the prediction analysis, we grouped by crew counts, dates, and utilized the linear regression slope. And we set up and organized the data frames for, firstly, linear regression with the actual data, and we chose the bootstrap analysis with 1,000 sample distributions. So for ACY inserts, we found that after accounting for the 50-to-1 or excluding the 50-to-1 unit conversion that we originally did, there would be 61 ACY insert boxes remaining after 60 days. And we did the same exact modeling for KTO and food US. And we did the same exact thing for the rest. So in conclusion, we cleaned and enriched the dataset, we visualized and analyzed the data, and we performed linear and logistic regression analysis, and as well as bootstrap modeling. We created supervised and unsupervised machine learning models to predict future trends. And going forward, we could train new models for better accuracy while taking account for other variables, other potential variables that Barrios may provide, such as passenger age and weight.